Welcome friends. So in previous sessions we had discussed theory part of the chapter motion in a straight line. Now let's try to solve examples or problems based on the things which we have learned in this chapter, right? Now for there can be n number of different variety of numericals or problems thrown to you. The key is that you understand the concept well, then you read the data which is given very carefully, interpret, write down what is given and what is to be calculated, write down the formulas which are related to the items which are to be calculated or which are given, and then try to find out how many unknowns are there. So if you have two unknowns, you require two equations. If you have one unknown, you can have one equation. So based on all this permutation combination, you can very easily solve the problem. So problem solving or example solving or numerical solving is a technique. You cannot mug up the examples. There can be always new variety of examples in the exam. So you have to learn how to solve any example. Of course, different variety of examples are having a pattern. So one variety of pattern we are starting over here. So this is nothing but let's read the data. A car starting from the rest moves with the constant acceleration x, then it moves with the constant deceleration y and becomes stationary. If the total time elapsed during this is t, what was the maximum velocity of the car? Right? Let's try to understand the problem. Here I'm going to solve two problems only in this video, but we would like to understand how to analyze and how to strategically, systematically understand the given problem, right? So that is the art which is what we would like to cultivate through this practice videos, and then you will be able to solve any problem given to you on a given topic. Sure. So let's read it again. A car starting from the rest. What is the meaning? That the initial velocity is zero because it is starting from the rest. So that is the meaning. Initial velocity is zero. Then it moves with constant acceleration y. So this is the first case. You can say case 1 when it has started, and then it starts with v0. Then acceleration is x meter per second square. Then it moves with constant. So let's say it has done it for some time. Say for time t1, this has happened, right? Now case 2. Now after t1 seconds, what is going to happen? That it moves with the constant deceleration. So speed has reduced now. So acceleration is now negative, minus y, deceleration. So I say it is minus y. And then it becomes stationary. So what I know, the final speed in this case is 0. And let us say this happened for t2 seconds. So total time was t1 plus t2. So in the object was over here, suppose at point A, and then it has reached point B. So this is where speed increased with acceleration is equal to x, and this much is suppose time t1, and here is time t2, during which, so this was v0 is equal to 0. Then so obviously when it was accelerating, at this point it has stopped accelerating and then started decelerating. So this is the point at which you have maximum speed Vm, and then it has decelerating with a is equal to minus y, and final velocity over here v is again 0, right? So you see this picture, this whatever drawing we have created is now giving me the clear idea about what has happened. So a vehicle started from rest, accelerated, reached a point where this velocity was maximum, and then suddenly now the destination was near. So it started reducing the speed, or it decelerated with the minus y deceleration, and finally after some time it has reached the 0 speed. Now what is the value of Vm? That is what we would like to calculate, right? So for that, we have to break this in two parts. So in first part, what is given? V0 is 0 and final velocity. So we'll solve the problem in parts. So first part or case 1 is for which V0 is 0, A is equal to X and T is equal to T1, and final velocity V is nothing but Vm, which is nothing but the maximum velocity, which is what we would like to calculate. So we know the formula governing all this. What is that? V is equal to V0 plus AT. So if we substitute, we get V is equal to Vm, V0 is 0 and A is X and this is T1, right? So this is the first relation which I am getting. You can say equation number 1. On this side, I'll go for the part 2 of this problem. So what is part 2? For part 2, this initial speed was Vm and the car started deceleration from this, and final speed is of course 0. Acceleration is minus y because it is nothing but deceleration, and then time duration is nothing but, let us say, t2. So we know the formula. V is equal to V0 plus AT. So if we substitute the values, V0 is equal to Vm minus y into T2, right? So you have Vm over here also. So how do I Vm can have only one expression. So from this, what do we have? Vm is equal to y into T2, right? So this is equation number 2. Now we would like to have expression for Vm, which is a generalized expression, right? So we would like to find out how much is the total time t. So we know that total time t is t1 plus t2. Now for first duration, for this the situation was that speed was increased from 0 to Vm, right, in this t1. So what do we know? Time is nothing but velocity divided by distance. We have acceleration A is equal to V2 minus V1 divided by time interval, say T2 minus T1. So here the time interval is T1. So therefore this T1 is nothing but, you can say, V2 minus V1 divided by acceleration. Now what is V2? V2 was Vm over here and V1 was 0. So Vm minus 0 divided by acceleration was x. And in second case, the final speed was 0, initial speed was Vm and deceleration was minus y. So that is this T2 value and that is equal to T. So if I simplify, Vm divided by x, minus minus will get cancelled, plus Vm divided by y is nothing but T, right? So if I take Vm common, I get x plus y divided by xy is equal to T. Or can I not say the expression for Vm is nothing but xy divided by x plus y into T, right? So this is the answer. So this is going to be the expression for maximum velocity with the given case, right? So this is how we have to break down the given problem in parts if required. We have to understand what is given and we have to find out what is unknown. So let's continue with the next problem. Okay, so next problem is, let's read the statement. A car moving over a straight path covers a distance x with constant speed of v1 and then the same distance with the constant speed v2. Average speed of the car can be obtained by the formula, right? Now this is a very straightforward problem where the distance is given and speeds are given, but the average speed over the entire duration is to be calculated. So let's try to solve this example. Now, what is the average speed? First, we have to understand the average speed v is given by the total distance divided by total time. So total distance is already known, 2x, x plus x, and total time, let us say the first movement was for t1 second and second was for t2 second. So if I find out t1 and t2 in terms of the velocity v1 and v2, I can find out the average speed, right? So what do we know? The first movement was with the constant speed v1. So what is this v1? v1 was with x divided by t1, or t1 is x divided by t1. Similarly, v2 is same distance, x was covered in t2 second. So we have t2 is equal to x over v2. So if I substitute in this, what do we get? It is 2x divided by, this is x over v1 plus x over v2, right? So x I can take out common, so it is going to you can say x times into bracket 2 over 1 over v1 plus 1 over v2, and here also x, so x gets cancelled out. So what remains, it is 2 over, if I simplify, this is going to be v1 plus v2 divided by v1 v2, right? And if I take denominators, denominator comes into numerator, so it is 2 times v1 v2 divided by v1 plus v2, right? So this is the final answer. This is the average velocity v, right? So this is the final answer, the usual units, meter per second square, meter per second, sorry, right? So this is how a given problem is to be understood. For first, read the data carefully, write down what is given, write down what is to be calculated, plan a strategy, and then execute. So the basic formulas are used over here. This example was a simple one, and this is how we'll be solving the category wise different problems of the motion in a straight line. That's all from me in this video. Thank you.